Hello dear students, welcome to mathematics class. So in this class let us discuss with the theorem on the subgroup. So here it is the statement of the theorem. Let G be a group and H is a finite subset of G, then H is a subgroup of G if and only if the first condition A comma B belongs to H, it implies AB belongs to H, and for any A belongs to H, it implies A inverse belongs to H. So here it is given that G is a group. Group means already G has satisfied all the four properties. They are closure law, associative law, identity and inverse. And H is a subset of G. Then we need to prove that H is a subgroup if these two conditions satisfied, and in the next part, if these two conditions satisfied, then H is a subgroup. So here in the first part we need to consider that H is a subgroup and we need to satisfy or we need to prove these two conditions. And in the next part, we should consider these 2 points as the given data and we need to prove that H is a subgroup. And to prove H is a subgroup, we need to show that H is independently a group under the given binary operation. So now let us move towards the proof. Let G be a group. So it is already given G is a group, and now let H be a subgroup of G. Now here G is a group, it is given already, and now consider that H is a subgroup of G, that is H is a subgroup of G. Now this as the given data and it implies H itself a group. So now H is a group independently, not depending on G. So now to prove, here we need to prove that whenever H is a subgroup, then first condition that for all A comma B belongs to H, it implies AB belongs to H. Second one, for any A belongs to H, it implies A inverse belongs to H. So here these 2 points we need to prove when H is a subgroup. Now since H is a subgroup, because already it is given H is a subgroup, therefore H satisfies all the 4 laws. They are, already we know that they are closure law, associative law, identity law and inverse law. So these 4 laws satisfied by H. So that's why it is a subgroup. Now by closure law, so already H satisfies all the 4 laws. So among that I am using closure law. So by closure law, what is the statement of the closure law? For all A comma B belongs to H, it implies that AB belongs to H, right? So therefore our first point is what? For all AB belongs to H, it implies AB belongs to H, right? So therefore for all A comma B belongs to H, it implies that AB belongs to H. So therefore the first point is over. So by using the closure law. Then let us move towards the second point. So, here we have A inverse belongs to H. So, that is why we can use the inverse property. So, by inverse law, for all A belongs to H, there exists A inverse belongs to H. So, that is the statement of the inverse law. So, therefore, here we can write as for any A belongs to H, it implies A inverse belongs to H. So, means any subset of a group G is a subgroup if it satisfies closure law and inverse law. No need of satisfying means no need to check the associative law and identity law, because this is the condition. H is a subgroup of G if and only if, here H is a subgroup of G if and only if these two conditions are satisfied. Means if these two conditions satisfied, then H is a subgroup, or whenever H is a subgroup, then these two conditions will satisfy. Now, we have proved the first part by considering H as a subgroup of G, and we have proved the first point and second point, that is closure law and inverse law. And then next we need to prove the converse part. Conversely, let A comma B belongs to H, it implies AB belongs to H, and for any A belongs to H, it implies A inverse belongs to H. So, these two conditions are given. Let us consider these 2 points as the given data. And to prove, here we need to prove that H is a subgroup of G. H is a subgroup of G. So, to prove H is a subgroup, we should satisfy the 4 laws. They are closure, associative, identity and inverse. Now, first one, by given. So, here 2 points are given, here I am using the first one. So, by given we can write for all A comma B belongs to H, it implies that AB belongs to H. So, it is similar to what? For all A comma B belongs to H, it implies that A star B belongs to H. This is nothing but the closure property. So, therefore, here already it is given that in H this property holds good. So, that is why, because it is given means already it is satisfied in H. So, therefore, closure law satisfied. Closure law satisfied. Then second one. Now, second one is associative property. Associative law. Now, for all A, B, C belongs to G, it implies that A into B C equal to AB into C. A into B C is equal to AB into C. Here we can write that because G is a group. So, any group has to satisfy the associative property. So, that is why for all the elements in G, associative property holds good, because here we can write that since G is a group. And now, H is a subset of G, means whatever the associative property for elements of G, they must be true for the elements of H, because all the elements of H are belongs to G only. So, therefore, it implies that A into BC is equal to AB into C for all ABC belongs to H. So, here all the elements of H belong to G, and those elements which are in G are already satisfied the associative property. So, therefore, the same elements are there in H, hence they have to satisfy the associative property. So, that is why this property holds good in H. So, it implies that H is associative. H is associative. Then remaining two properties, they are identity and inverse. Now, again the third point is, you can use the given condition by given. So, here second point is given that for any A belongs to H, it implies that A inverse belongs to H. So, here we know the statement of the inverse law. So, for all A belongs to G, there exists A inverse belongs to G, right. So, means whatever the element are there in the given set, there exists inverse, means we say that that is the inverse property. So, therefore, here it is already given in H. For any A belongs to H, there exists A inverse belongs to H. Therefore, we can say that inverse property or inverse law satisfied in H. And the last one remaining, that is the identity property. Now let A belongs to H, it implies that A inverse belongs to H, that is the inverse law. So, inverse law already satisfied. So, that is why we are considering that as the direct point, that A belongs to H, it implies A inverse belongs to H. Now, by the first condition, that if A belongs to H, A inverse belongs to H, then product of these two is also in H, that is a closure law, that is A inverse belongs to H. So, by we can write this as given. The first point is given, that is AB belongs to H, means the product of those two is also in H, hence A belongs to H, A inverse belongs to H, then product of them, that is A inverse belongs to H, and we know that A into A inverse is nothing but the identity element. So, that also E belongs to H. So, therefore, E belongs to H, it implies that identity law satisfied. So, therefore, all the four laws satisfied in H, all the four laws satisfied in H, it implies that H is a group. If H is a group and it is a subset of G, it implies H is a subgroup of G. So, here in this theorem, by considering here H be a group and H is a subset of G, then here it is the proof of the theorem, that is H is a subgroup of G if and only if these two conditions satisfied. So, in the first part we have considered that H is a subgroup. So, if H is a subgroup, then it implies that all the four laws are satisfied. So, here closure law, associative law, identity law and inverse law. If all these four laws satisfied, then H is a group, that is given. Here no need to prove that H is a subgroup, because here H is a subgroup is given, then we need to prove these two. So, that is why by using closure law and inverse law, we have satisfied those two conditions by using closure law, that is a statement, hence it proved, and here inverse property, that is also proved. So, it is the first part, and in the second part, means in the converse part, we need to consider these 2 points as the given data, and we need to prove that H is a subgroup. whenever we need to prove the subgroup condition, we have to satisfy the 4 properties for the given subset. They are closure law, associative law, identity law and inverse law. So, here we have proved closure law, associative law and inverse law, identity law. So, hence all the 4 satisfied means that is a group, and already it is given that it is a subset of G. So, if it is the subset, then it is the subgroup if it is a group. So, therefore, we have proved H is a group, hence it is the subgroup of G.